let's start by labeling that x-axis. The x-axis is talking about the year. The y-axis, 24.8, 24.9, 25.0, etc., is representing what?
Age.
The age. And all that information can come from your table. The first column is your year, that's x. The second column is age, is y. Any measure of time is probably going to be your x value. So in my, or on my graph, I'm going to label the y-axis as the age. It's important that you label your axis so the person reading your graph or interpreting your graph understands what your axes are representing. The first question here asks us to write an equation in slope-intercept form for the line of fit. Well, for this particular graph, they've already drawn in a line of fit. We need to select 2 points that are on this line. Would it be okay if I just pick any two data points on this? Any 2 data points?
No.
If I just pick any 2 data points, so what if I just pick these first 2 dots, or these 2 dots here? Would that be okay?
No.
Why? They have to be on the line. You can't write an equation that goes through 2 points if your points aren't even on the line. It doesn't help you. We're trying to write the equation of this line, so we have to pick points that are on this line. It just so happens that we do have 2 data points that fall on our line. We don't have to use those 2. We could use any point that is on our line. But I'm going to use those 2. So let's start by writing down the ordered pair for those 2 points. The first point right here would be, what does the year 00 correspond to?
2000.
2000, comma, 25.1.
Does it matter if it's like the other way around, 25.1?
Good question. Because our years are x-axis, use that as your x-coordinate of the ordered pair. That's a very good question. The second point that we're going to use is 2002, comma, 25.3. So I've got my 2 points listed. Let's go ahead and write our equation. The first thing we'll have to do is find what? Our slope. M equals, I'll do 25.3 minus 25.1 divided by 2002 minus 2000. 25.3 minus 25.1, I have 0.2 divided by 2. So my slope is 0.1. Now we need to find our y-intercept using one of our ordered pairs. I can't just look at my graph and find my y-intercept because we have a break here in the graph. So pick one of your ordered pairs, doesn't matter which one. I'm going to use the first ordered pair. So I have 25.1 equals 0.1 times 2000 plus b. 25.1 equals 0.1 times 2000 is 200 plus b. Subtract 200. So 25.1 minus 200. I got negative 174.9. Did you get that as your y-intercept as well?
Yeah.
Negative 174.9. Now that we have our slope and we have our y-intercept, let's write an equation. Y equals 0.1x minus 174.9.
It's okay if it's just 0.1.
Yeah, I have 0.1 but if you have 0.1, that's fine. The next question says to predict the median age of females when they are first married in 2016. So 2016, that's a year. Is that our x or is that y? If you look at your graph, your years are on the x-axis. axis, so we're going to put 2016 in for x. So let's use the equation. We're not just going to use our table. I want you to use your equation that you just created to help you predict the median age of females who are married in 2016. So 0.1 times 2016. I have 26.7. Is that what you got? Okay, we found that y was equal to 26.7. Well, what is our y measuring? It's age, so it's in terms of years. 26.7 years. Does that seem to be a reasonable answer for this data? I think so. What if it was negative 26.7 years? Probably not reasonable. Can't be reasonable. You can't be negative 26.7 years. Be sure you are labeling that data after you figure out the answer. On the back side, let's go ahead and look at it. It says use the scatter plot of Buffalo Bills. So like on the x-axis, we've got years since 2000. So on that x-axis, what does 3 represent? 3 years. So what year would 3 years since 2000 be? 2003. So that 3 is representing the year 2003. What would the year 4 represent? 2004. The year since 2000. What about 6? And 7? 2007. Okay, so we're okay with what that means. On the attendance is on the y-axis. We're talking in terms of thousands of people. In example A, it says to use the points 3, 73,000 and 6, 67,650 to write the slope-intercept form of an equation for the line of fit shown in the scatter plot. Right now, I would like for you to take a second and write your equation for part A. If you get done, you can go ahead and do part B if you would like. For sure, go ahead and do part A right now if you would. Okay, so the first thing we should have done is find the slope of the line that goes through those 2 points. So 67,650 minus 73,000 divided by 6 minus 3. Some of you left it as a fraction, which is fine. Some of you went ahead and made it a decimal, which I'm okay with as well. You can read this here. It says negative 1,783.3. Negative 1,783.3. Next, I'm going to use one of my ordered pairs, and I'll use the first one to help me find B. Negative 1783.3 times 3. Now, depending on how you round it up here or if you use your fraction, you may get a slightly different answer than we're going to get down here, which is fine. Remember, if you're close, you're probably correct. For example, I know Caitlin got 78,350. Anybody else get that? I got 78,349.9. It's close.
That's okay.
Yeah, and that's fine. If they're close like that, I'm going to give it to you. It just depends on how you rounded. If you rounded fine or correct, you're going to get it. Okay, so let's write our equation. We have y equals 1,783.3x plus 78,349.9. How many of you got that correct equation correct on your own? Good. Part B says to predict the average attendance at a game in 2012. Okay, obviously years are X value, but be careful, they're not using the exact year, are they? They're talking in terms of years since 2000. So how many years since 2000 is 2012? 12. So in my equation, I'm going to let X be 12, not 2012. If you use 2012, that's 2012 years past the year 2000. That's way, way, way ahead of time. When I put 12 in, I'm going to add 78, 349.9, I get approximately 56,950.3. So we're talking in terms of attendance. Why is your attendance? So what are we talking? What's our label? People. And if you rounded to 56,950 people and you took off the 0.3, that would be okay. Because you really can't have 0.3 people here. I would take either answer. Part C says, can you use the equation to make a decision about the average attendance in any given year in the future? What's going to happen, well, if you look at your graph, first of all, look at your graph. What looks like attendance for the Buffalo Bills? What's happening? Yeah, it's going down and down and down until, I don't know, the Buffalo Bills pretty bad? Everybody know? Pretty bad. Okay, so what happens, let's say the Buffalo Bills have a really good year. What's going to happen to their attendance? It's going to go up. What happens if maybe the Buffalo Bills get a state-of-the-art new facility, they've got the best of the best, they're doing really good. What's going to happen to that attendance? It's going to go up. Is that going to jive with what's happening according to this graph? The graph is going down and down and down and down and down and down. It doesn't literally show any signs of going back up. So what do you think on C? Can you use the equation to make a decision about the attendance in any given year? What do you think? I'm going to say no. There's too many variables. There's too many things that could cause the attendance to change. I would say no.
Would this be an opinion question on
Yes and no. I definitely don't think this, I think it's a definite no. But as far as explaining why, that would be an opinion. Okay, so fluctuate, F-L-U-C. It's close. There are too many things that could cause the attendance to fluctuate. So I'm going to say definite no. Okay, tomorrow we do have a quiz over section. Quiz tomorrow will be over section 4.4 and 4.5. We'll review briefly, very briefly before your quiz tomorrow. Tomorrow we'll probably go over parallel and perpendicular lines. That's probably all we have time for before we take our quiz. So definitely parallel and perpendicular lines. If I gave you an equation of a line that, say, your line was parallel to, and I gave you a point that your line went through, could you write an equation? Told you they were parallel. What if I told you they were perpendicular? Could you write an equation with those? Should be able to. If two lines are parallel, what do they have in common?
Same slope.
The same slope. What if two lines are perpendicular? What do they have in common? Their slopes are opposite reciprocals. Could you write an equation for a word problem? If I gave you an ordered pair, if I gave you a slope and a y-intercept. If I gave you a scatter plot, could you draw in a line of best fit? Describe correlation, write an equation, use the data to make a prediction about the future. And there's a couple of review problems. Can you solve equations? Can you evaluate functions, like f of x, like f of 3, for example? The quiz is pretty short, it's just front and back of one sheet of paper. I'm also going to give you your study guide. Your study guide for this chapter is going to be out of your book. There are a few problems I've given you that are going to be on graph paper. And there's some book assignment problems. This is not due until Wednesday. You'll have time after your quiz tomorrow to work on your study guide in class. And we'll go ahead and give it to you along with today's assignment. I'll give you today's assignment first, and then I'll pass out your study guide. Today's assignment is going to be a scatter plot worksheet. There are 2 sides to it. It's going to come out of the book. Comments are out of the book except for the few. Yeah, they're all out of the book. If you guys would like to group up and work with someone in class for the remaining about 15 minutes, you may do that as long as you're